fractions. That'll all be on your assessment on Monday. So assessment tomorrow, review Friday, assess on Monday. That is the schedule moving forward. All right. Beginning with our definition, and this is not just a definition that we are going to need to know for this. It is a definition that we will continue to use throughout the year this year. Okay? Now, when I went through and tried to figure out, like, what's the best way for me to explain to students what a reciprocal is? I'm going to explain it in a couple different ways, but I love this definition because this is the idea we're going to use in a couple of weeks. So I don't want to have a definition now and then define it later on. Reciprocals are this: two non-zero numbers whose product, what's the word product mean? Multiplication. It's the answer to a multiplication problem. Two non-zero numbers whose product is 1. Two non-zero numbers whose product is 1. I'm going to give you some examples of these. So then you can start to see some relationships and everything else. Okay? Now the first one I'm going to give you actually isn't even a fraction, even though we've been talking a lot about fractions. So here are some examples of reciprocals. Two. If I started with 2 and I asked what is the reciprocal of 2, I'm asking 2 times what is 1? Who can tell me what the reciprocal of 2 is? And remember, if you're questioning what it is, it has to fit this definition. What is the reciprocal of 2? Okay, but what's 2 times 2? 4. That product is not 1. What's that? Okay, what's 2 times 1? 2. That's not going to be reciprocals. There is a reciprocal. I didn't say it's a whole number. Caitlin, you were super excited back there. What is it?
Oh my gosh, I don't know. It's either a fraction or a decimal.
It is it actually can be both. Use your calculator. What's 2 times a half? It's 1. Those are reciprocals of one another. Think about it like this. If I have a half a cup of sugar, how many half cups do I need for a cup? I need 2. Those are reciprocals of one another. Their products is 1. Okay? 5 is 1/5. If you multiply 5 and 1/5 together, you get 1. 1/8 is 8. If I take 8 times 1/8, I get 1. Four over 5. If I take 4 over 5 times 20, though, that's going to give me 16. Because look what happens when I multiply these together. What's 4 times 5? What's 5 times 4? What's 20 over 20? Those are reciprocals. 3 over 7.
Negative 6 over 5.
So, when you look at fractions, what's an easy way to describe to somebody to find a reciprocal? You flip what? You flip your numerator and denominator. When all you have is a fraction, like this, to find its reciprocal, you simply flip the numerator and the denominator. Again, if you don't understand why, when you find the product of each of these problems, this is 20 over 20, which is equal to 1. This is 21 over 21, which is equal to 1. This will equal 30 over 30, which is equal to 1. So anytime that I have a fraction, in order to find its reciprocal, I simply flip the numerator and denominator. Now, believe it or not, that is really what you're doing here as well. Except 2 isn't a fraction, but you can make it 1 by doing what? Putting it over 1. Flip the numerator and denominator, you get a half. How can you write 5 as a fraction? 5 over 1. Take your numerator and denominator, flip them around, you get 1/5. Take this numerator and denominator, flip them over, you get 8 over 1, which is 8. So this works even with whole numbers, as long as you remember that a whole number has a 1 at the bottom of it if I were to write it as a fraction. Again, we're going to talk about this today, but we're also going to be talking about it next unit as well. Now, why am I talking at all about reciprocals? Because in order to divide fractions, we're not actually going to do division, we're going to do multiplication. But there's some things that have to happen in order to do this. So read what we have right here. To divide fractions, multiply the first fraction by the reciprocal of the second fraction. So we're changing the division to multiplication, and we're changing the second fraction. We're going to flip the numerator and denominator. Okay? And then as always, check to see if the answer is written in simplest form. Now I have 3 blanks down here, because I have a little saying that I borrowed from a student of mine when I first started teaching, and she kind of just ingrained it into our mind and we continue to use it. Her phrase for dividing fractions is keep, change, flip.
Yeah, I remember this. It was KFC.
I've heard KFC as well. So, what does keep mean? Keep the same fraction. Change means change the operation to multiplication, and flip tells us flip the numerator and denominator, which is the same thing as we do to find a reciprocal. Keep, change, flip is how we are going to always do a division problem with fractions. Again, ultimately, our first step when we do a division problem is to use keep, change, flip to make it into a multiplication problem. Okay? So, I'm going to zoom in on this a little bit so we can see these a little bit easier as we go. Now, it's important that we know how to multiply fractions, like I've said. Like, we learned something one day and we expect you to be able to use it the next. Yesterday we focused on multiplying fractions. That's what we're going to be doing today. So, if I were to take a look at example 1a, in our work what I would expect to see, we're going to keep the first fraction. We're going to make this 8 over 21. We're going to change our operation from division to multiplication. And we're going to flip our second fraction and make this 14 over 9. Now, what's the rule when you multiply a fraction by a fraction? Multiply straight across. Top times the top and the bottom times the bottom. So, we can reduce first, which is something I'm going to do here. Now, here's one thing I want to point out though, talking about reducing. You can't reduce, some people are like, well, can I reduce these because they're both even? No. We don't do reducing until you change it to a multiplication problem. So, the problem with trying to divide those each by 2 is we're actually moving the 14 to the top. So it's not going to reduce with any of the 8s on the top. So make sure you do your keep, change, flip before you reduce. All right, somebody give me a factor we're going to be able to divide out of here. Serena, 7. 21 and 14 are both divisible by 7. What's 21 divided by 7? 3. What's 14 divided by 7? 2. Can we reduce any other factors? No. So now we're going to multiply straight across. 8 times 2 is 16. 3 times 9 is 27. We're going to be left with 16 over 27. And again, it probably wouldn't be a bad habit that you've at least confirmed that you can't reduce this by looking to see if 16 and 27 are both relatively fine. Which they are, so we're good with that. Okay, now, something to think about with B, just so it doesn't kind of get lost in our work. We're taking a negative dividing by a positive. My answer should be a negative. When my signs are different, this is going to turn out to be a negative answer. So, when we go to do this, my suggestion is to put the negative, let's put it with the top. So if we use our keep, change, and flip, we're going to have this. Keep the first one as negative 2 over 5, change division to multiplication, and flip it 4 over 7 to be 7 over 4. All right, common factors at all? Yeah. Yes. What is it? 2. If we take negative 2 divided by 2, we get negative 1. If we take 4 divided by 2, we get 2. Any other common factors? No. Negative 1 times 7 is negative 7 over 2 times 5, which is 10. Our final answer should be negative 10 or negative 7/10. All right, I want you guys to try C and D. Make sure that you've included the work and not just here's the answer to it. Keep, change, flip. Whether you want to multiply first and reduce second, reduce and then multiply, that is completely up to you. And again, something to think about when you look at your numbers. Before you just do the problem, should my answer be a positive or a negative when I get done? That's what you got to ask yourself. Alright, so here's what I was talking about with C. My first number is negative. We're dividing by my second number, which is also negative. And we know that a negative divided by a negative should be a positive. My answer to this problem should be a positive. So if I have negatives in my answer, I need to reduce that to become a positive. So, keep. I'm going to go ahead and put my negative at the top. Change. Now, here's where you want to think a little bit ahead. Most of the time we put the negative at the top. But what am I doing with this number? I'm flipping it. So I'm going to put my negative with the 6 if that's what I'm comfortable, if I always like my negatives to be on the top. Some people ask, well, where does the negative go? It doesn't matter as long as you don't put it with both of them. Now, any common factors here? Yes, what? 3. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. Any other common factors? No. All right, what's negative 2 times negative 2? Positive 4. And 1 times 5 is? There's my final answer, 4/5. Now, if you multiplied right away, because I know some people as I walk around, you're doing this, that's fine. You'd have this. What's negative 2 times negative 6? 12 over 3 times 5, which is? Okay, but what would you have to do with this? You'd have to divide top and bottom each by what? By 3. And that's going to leave you with that same answer of 4/5. So just like we did yesterday, you can multiply first and then divide. You can divide first and then multiply. That is completely up to you. Alright? Letter D, a positive divided by positive should be a positive. This answer should be positive. Keep 7/12. Change division to multiplication. Flip the second fraction to be 3/2. Any reducing? Yeah, what? 3. 12 and 3 are both divisible by 3. So 12 divided by 3 is 4. 3 divided by 3 is? Any other common factors? No. 1 times 7 is 7. 4 times 2 is 8. We have 7/8. If you multiplied right away, you'd get 21/24. Both which can be reduced by 3 to give you 7/8. Alright. Questions on this? So, what do you think is the only difference when we start throwing in mixed numbers? Change them to impropers. So, let's flip to the back page. So, as it says, to divide mixed numbers, change them to impropers. Then you're going to continue to use the exact same rules. We're going to keep the first, flip the second, and change division to multiplication. Alright, so, what do we do with a negative mixed number when we start to change it to improper? What do we do with the negative? Ignore it. So, we're taking 4 times 3, which is 12, add 1 to get 13, over 4, bring the negative back in. Now, I'm not doing the keep, change, flip yet. I am simply changing this to a fraction divided by a fraction problem. 2 times 5 is 10, plus 1 is 11, over 2. Sometimes people want to change it to multiplication. Well, that's fine, but then they forget to flip it. And they start getting all this wonky stuff. Change them to impropers first, then follow through with what we did on the previous page. Use your keep, change, flip. Negative 13 over 4. Change division to multiplication. Flip the second to be 2/11. Alright, do I have any common factors here? They're divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Any other common factors here? So let's go ahead and multiply. Negative 1 times 13 is, negative 13 times 1, negative 13. 2 times 11 is? Are 22 and 13 relatively prime? Yep, there's my final answer. Okay, let's take a look at example B. Again, a negative mixed number. We're going to take 4 times 5, which is 20. Add 1 to get 21. Then we'll bring the negative back into this. We're still dividing. I'm not changing anything other than mixed numbers to impropers. 2 times 5 is 10, plus 2 is 12. So this now becomes 12/5. Now we can go ahead and do our cube change flip. Negative 21 over 4. Change and flip 5 over 12. All right. Any common factors here? 3's. Negative 21 divided by 3 is negative 7. 12 divided by 3 is 4. Any other common factors? No. Negative 7 times 5? Negative 35 over 4 times 4, which is 16. There is my final answer. 35 and 16 are both relatively prime. All right. Again, we're going to flip the script now. You guys do see the... Yes, I do. Alright, so let's take a look. I got kind of up against the bell here, so I want to make sure I get through what I need. 5 times 4 is 20, plus 3 is 23, so 23 over 5. Divided by 10 times 1 plus 7 is 17 over 10. Keep, change, and flip. Okay? Do some reducing. 5 divided by 5 is 1. 10 divided by 5 is 2. That's all I could do here. 2 times 23 is 46 over 17. Okay, let's not be packing up, ladies and gentlemen, quite yet. Second one. 4 times 6 is 24, plus 1 is 25 over 6. Divided by 3 times 1 plus 2 is 5 over 3. Again, I'm going to strongly encourage that you change to impropers before you do anything else. I saw some people that were able to do it correctly all in one step, and I saw a lot that didn't. Okay? Now, keep, change, flip. Two different things that I can reduce here. 6 divided by 3 is 2. 3 divided by 3 is 1. 5 divided by 5 is 1. 25 divided by 5 is 5. Now when I multiply straight across, 5 times 1 is 5. 2 times 1 is 2. My final answer should be 5/2. Again, if you want to multiply first and reduce second, that's fine. But I'm not going to tell you that you're going to always get nice small answers. Homework for tonight. Yes, it's all homework. Is page 251. 7 through 27 odd. We need to get through all of this during the third period. And maybe a little bit into 7th, but we have an assessment 7th that we need to be ready for.